Hello, 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 check, hello, 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 check, hello, 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 check, hello, 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 check, hello.
So morning polymerization, types of polymerization. సో మొబైల్ని ఒక టెక్స్ట్ బుక్ లాగా ఒక నోట్ బుక్ లాగా ముందట పెట్టకండి. లోపల బ్యాగులో పెట్టేసేయండి. అదొక ఎసెన్షియల్ థింగ్ లాగా అయిపోయింది. బుక్ పెన్ లాగానే మొబైల్ పక్కన చదువుకునే వాళ్ళకు అదొద్దు. సైలెన్స్ నాట్ డిస్ప్లే అట్లా పెట్టకండి, లోపల పెట్టేసేయండి. ఇప్పుడు ఏదైనా ఫోన్ వచ్చింది అనుకో కనబడుతుందిగా మీకు, లేదా ఇట్లా రివర్స్ లోపల పెట్టేసేయండి, బ్యాగులో పెట్టేసేయండి. సో మార్నింగ్ మీ బ్యాచ్ కాదు కదా, వేరే మీరు లైవ్లో విన్నారా? విన్నారా క్లాస్? సో టైప్స్ ఆఫ్ పాలిమరైజేషన్ ఇంకో క్లాస్ వాళ్ళు వస్తారా? ఫ్రీ రాడికల్, addition polymerization. Second one is condensation polymerization. And third one is coordination polymerization. Coordination polymerization. So in the morning session, we completed addition polymerization. Addition polymerization. So what is addition polymerization? It is a polymerization in which the monomers are added to each other. The monomers are added to each other based on the reagent. Addition polymerization classified into three types: free radical addition polymerization, cationic addition polymerization, anionic addition polymerization. Right? So in that we completed free radical addition polymerization and mechanism also. Okay, free radical addition polymerization and mechanism. So what is free radical addition polymerization? It is a addition polymerization which is initiated by the free radicals. Free radicals are initiated the free radical addition polymerization. Okay, and what are free radicals? What are active sites? What are free radicals? The morning classes winner. Morning class. వెళ్ళలే? ఎట్లనో వెళ్ళలే మేడం, మళ్ళీ వీళ్ళకు వీళ్ళు లైవ్ లో విన్నారా వేరే? అదే వీళ్ళు మార్నింగ్ వేరే లైవ్ లో విన్నారా? ఆన్లైన్ లో విన్నారా? విన్నారా మార్నింగ్ లైవ్ లో? ఎస్ ఆర్ నో? మీ మీ రెస్పాన్స్ రావట్లేదు. Addition polymerization. Okay, clear. Condensation polymerization, coordination polymerization. సో లెట్స్ మీరు ఎక్కడి వరకు విన్నారో దాన్ని బట్టి నేను నెక్స్ట్ క్లాస్ స్టార్ట్ చేస్తాను. సో ఇన్ ద మార్నింగ్ సెషన్ వి కంప్లీటెడ్ అడిషన్ పాలిమరైజేషన్. ఓకే, విన్నారా? రైట్. సో నెక్స్ట్ కండెన్సేషన్ పాలిమరైజేషన్. సెకండ్ వన్ కండెన్సేషన్ పాలిమరైజేషన్. సో కండెన్సేషన్ పాలిమరైజేషన్. మేడం వేరే సెక్షన్ వాళ్ళు వస్తున్నారా? ఆగా. फुल बात करनी. So what is polymerization? What is polymerization? Not responding. You are not responding. You are not listen in the morning session. What is polymerization? Just definition. Polymerization definition. Resound. Sound. You are not లైవ్ లో ఉంది. ఇంత ముందాలే. So condensation polymerization. Okay. After 30 seconds repeated. Like, so what are the characteristics points of the condensation polymerization? What happens when condensation polymerization takes place? Okay, so let's see the all the points in the condensation polymerization. This is the definition of the condensation polymerization. And during the polymerization, so what types of monomers are involved, and what happens between the monomers, and what is the product? What is the product? Okay, and how many types of mechanism, how many steps the condensation polymerization takes place? Okay, so let's see all these points. Okay, so in this condensation polymerization, the functional monomers, the functional monomers, the functional monomers like OH functional group, COOH functional group, or amine functional groups. Functional monomers like OH, COH, NH2 are involved in the involved in this polymerization. In this polymerization. Okay, so which type of monomers are involved? Functional monomers. So functional monomers like OH, COH, and NH2 are involved in this polymerization. And in addition polymerization, double bonded hydrocarbons are involved in that polymerization. In the addition polymerization, double bonded hydrocarbons. But in this polymerization, the functional monomers are involved. The functional monomers which are having OH, COH like that. So these types of monomers are involved in the condensation polymerization. And the functionality of monomer, the functionality of monomer, the functionality of monomer, monomer, monomer is trifunctional monomer should be more than three, more than three. The functionality of the monomer should be more than three. Okay, so means the polyfunctional monomers. So wait, more than two. Okay, two are more than two. Okay, the functionality of the monomer should be more than two. So more than two are more than two. So the functionality of the monomer should be two are more than two. Should be two are more than two. Two aina లేకపోతే more than two aina ఉండాలి functionality. What is functionality? The number of active sites in a monomer is known as functionality. Number of active sites in a monomer is known as functionality, and that functionality should be two or more than two. Two or more than two. And next two. Next. So during condensation polymerization, byproducts are formed. Byproducts are formed. Byproducts are formed. And in the addition polymerization, there is no formation of the byproducts. But here, the byproducts are formed. So what types of byproducts are formed? Like water, CH3OH, and ammonia. So during this polymerization, byproducts are formed. And next to molecular weight of the molecular weight of the polymer, the molecular weight of the polymer is not multiples of the monomer. Is not multiples of the monomer. So, but in the addition polymerization, the molecular weight of the polymer is multiples of the monomer, but here it is not. So the molecular weight of the polymer is not multiples of the monomer. Okay, and next to the mechanism of this polymerization, the mechanism of this polymerization not takes place in not takes place in 3 steps. Not takes place in 3 steps. Okay, but that addition polymerization is carried out in 3 steps. What are they? Initiation, propagation, and termination. But in this mechanism, that polymerization not takes place in the 3 steps. It completed in only single step. It completed in only single step by loss of the molecule, by loss of the byproducts. So this condensation polymerization is completed in single step only. But addition polymerization completed in 3 steps. 3 steps lo adi complete avute idi only single step lo complete avutundi. Okay, that is the difference between addition and condensation polymerization. Addition and condensation polymerization differences annamata. Okay, and next it is not a exothermic reaction. It is not a exothermic reaction. So this polymerization is not a exothermic reaction. It is not a exothermic reaction. So these are the main points which are covered in the during condensation polymerization. So during condensation polymerization, these are happens in that reaction. Okay, what are they? What are the points? The functional monomers are involved in the this polymerization. So what are functional monomers? Which are containing OH2, COH, or NH2 groups like that. And the functionality of this monomer should be 2 or more than 2. And during polymerization, there is no formation of the byproducts. During polymerization, byproducts are formed. And next, the molecular weight of the polymer is not multiples of the monomer. And the mechanism of this polymerization not takes place in 3 steps. And it is not a exothermic reaction. For example, if question asked like this, write the differences between addition polymerization and condensation polymerization. అన్నప్పుడు ఈ differences రాయాలి. ఓకే, లెఫ్ట్ సైడ్ అడిషన్ అండ్ రైట్ సైడ్ కండెన్సేషన్ పాలిమరేషన్. అవే పాయింట్స్ ఇక్కడ కవర్ చేస్తూ చెప్పాను ఇది. అవే పాయింట్స్ ఇక్కడ కవర్ చేస్తూ చెప్పాను దానికి దీనికి డిఫరెన్సెస్. ఓకే, ఒకవేళ అడిగినా కానీ మీరు రాయగలగాలి. ఓకే, అండ్ నెక్స్ట్ ఎగ్జాంపుల్స్ ఆఫ్ ది కండెన్సేషన్ పాలిమరైజేషన్. Examples of the condensation polymerization. So here I take 2 monomers. So the monomers are, one is the monomer which contains the COH functional group, COOH functional group. I take here n number. So the name of this monomer is terephthalic acid. Terephthalic acid. Terephthalic acid. The name of this monomer is terephthalic acid. It is a dicarboxylic acid. It is a dicarboxylic acid. What is the name of this monomer? Terephthalic acid. Okay, and plus, and another monomer I take here ethylene glycol. Ethylene glycol. CH2OH. 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 So the name of this compound is ethylene glycol. Ethylene glycol. So these monomers are involved in the condensation polymerization. How these monomers are condensed? ఎలా కండెన్స్ అవుతాయో చూద్దాం. So here the condensation takes place between the functional groups. Okay, the OH of carboxylic acid, the OH of carboxylic acid. See, here the OH of carboxylic acid and H of alcoholic group. H of alcoholic group are eliminated as water molecule. Are eliminated as water molecule. So how many water molecules are eliminated? So during the condensation, 2n number of water molecules are eliminated. See, OH group and H. OH and H are combined together form a water. OH minus H plus. OH minus and H plus combined together and form a water molecule. So like that. So during the condensation, water molecules are eliminated. Okay, and by the elimination of the water molecule, see here the polymer is formed. The polymer is like this. So this is the polymer. This is the polymer which is formed by the condensation polymerization, which is formed by the condensation polymerization. So in this, see, so this unit is repeated. This unit is repeated number of times. What is the unit? What is the what is this functional group? And this functional group is also known as ester. Ester functional group. That group repeated how many times? N times. That group repeated how many times? N times. So that ester is repeated number of times, so that this polymer is known as polyester. It is known as polyester. Polyester. Okay. So here this is the one of the example of condensation polymerization. Okay. See, in this polymerization, one monomer has two carboxylic acid groups, and another monomer has two alcoholic groups. In between these, the condensation takes place by the loss of the water molecule, and here the polymer is formed, and in that polymer this unit is called as ester group, and that unit is repeated number of times, n times, so that it is known as polyester. So this is the one of the specific example for the condensation polymerization. And next, second example. So the mechanism is like this only. Okay, so there is no another further steps. Only it completed in one step. It completed in single step only by the loss of the water molecule or by the loss of the byproducts. Okay, and next to second example. Second example. See, CH2. So take 4 COOH, COOH. This is the second example, first example and second example. Okay, this is the one of the monomer. It has two carboxylic acid functional groups, COH and here COH. And then with this, I take another monomer which is having alcoholic group, that is hexamethylene diamine. Amine group, that is hexamethylene diamine, NH2, NH2. Hexamethylene diamine, hexa means 6. Okay, hexamethylene diamine. So in these monomers, here the condensation takes place. The condensation takes place. By the condensation, see, the uh, OH of the carboxylic acid and H of the amine group, are eliminated as water. H of the amine group eliminated as water. Here 2n number of water molecules are lost. 2n number of water molecules are lost, and by that here a polymer is formed. Like this. So here left side also that OH group is eliminated during the condensation, and from this right side also H group is eliminated as water in the condensation reaction. So that what units are remains in the polymer? So the remain structure of the polymer is like this: CO, CH2, take 4, and CO, NH, CO, NH, CH2 take 6 times, and NH. So this unit is repeated in this polymer. In this polymer, this unit is repeated. This unit is repeated. So in this unit, see that CO double bond NH, that CO double bond, C double bond O NH is known as amide, known as amide group. Amide group, that amide group repeated n number of times so that it is known as polyamide. It is known as polyamide. The name of this polymer is nylon. Nylon 66. The name of this polyamide is known as nylon 66. Okay, so nylon cloths antam కదా. So the chemical composition of the nylon is, this is the general chemical composition of the nylon. Okay, right? So this is the condensation polymerization. So during condensation polymerization, what happened here? The water molecules are lost. The water molecules are lost, and finally the polymer is produced. The polymer is formed. Okay. So why this polymer is called as nylon 66? Why 66? Why it is 66? So see, 6 carbons comes from this unit, this monomer, and another 6 carbons comes from this monomer, so that it is called 6,6. Okay, so the polyamide is also known as nylon. So nylon 6,6 అని ఎందుకు అంటున్నామంటే 6 carbons coming from this monomer, and remaining 6 carbons are coming from the second monomer. ఓకే, సెకండ్ మోనోమర్ నుంచి 6 కార్బన్స్ అండ్ ఈ మోనోమర్ నుంచి 6 కార్బన్స్ వచ్చాయి కాబట్టి సో మనం ఏమంటున్నాం దాన్ని నైలాన్ 6,6 అంటున్నాం. సో దిస్ ఇస్ ద సెకండ్ ఎగ్జాంపుల్ ఆఫ్ ది కండెన్సేషన్ పాలిమరైజేషన్. ఓకే, సో నెక్స్ట్ క్లియర్, అర్థమైంది. సో ఏదో ఒక ఎగ్జాంపుల్ రాస్తే సరిపోతుంది. సో నైలాన్ 6,6 మనకు సపరేట్గా ఉంది. సో దాని గురించి మళ్ళీ సపరేట్ డీటెయిల్డ్గా నేర్చుకోవాల్సి వస్తుంది. సో ఏదో ఒక ఎగ్జాంపుల్ రాస్తే సరిపోతుంది కండెన్సేషన్ పాలిమరేషన్కి. రైట్. సో నెక్స్ట్ థర్డ్ వన్ కోఆర్డినేషన్ పాలిమరైజేషన్. రాసారా? కోఆర్డినేషన్ పాలిమరైజేషన్. కోఆర్డినేషన్ పాలిమరైజేషన్. కోఆర్డినేషన్ పాలిమరైజేషన్. Coordination polymerization. So it is also called Ziegler-Natta polymerization. Ziegler-Natta polymerization. It is also called Ziegler-Natta polymerization. So what is the coordination polymerization? So it is a stereospecific polymerization. Stereospecific polymerization. It is a stereospecific polymerization means the arrangement of 11. So the arrangement of functional group. Arrangement of functional group is either top side or alternative. All the functional groups are arranged either top side or alternative. So that is what specific, stereospecific. Okay, so it is a stereospecific polymerization, and in that isotactic polymers are syntactic polymers are formed. Isotactic and syntactic. Isotactic అంటే ఏంటి? What is tacticity? సో దాని గురించి ఒక 1 minute. Tacticity. So what is tacticity? Tacticity is the arrangement of functional groups. Arrangement of functional groups in a polymer is known as tacticity. Arrangement of functional groups in a polymer is known as tacticity. So based on tacticity, the polymers are three types: isotactic, isotactic polymers, syndiotactic polymers, atactic polymers. So ఏం చెప్తున్నా ఇక్కడ, what is tacticity? The arrangement of functional groups. The arrangement of functional groups in a polymer is known as tacticity. So tacticity, based on tacticity, the polymers are three types. What are they? Isotactic. So in the isotactic polymers, all the functional groups are arranged same side, either top side or down side, whatever. But the functional groups are arranged same side. If the functional groups are arranged same side, that those polymers are called isotactic polymers. For example, PVC undi. PVC, CH2, CHCl, CH2, CHCl, CH2, CHCl. So in this polymer, so what are the functional groups? Cl, chloride is the functional group. That chloride arranged same side, downside, same side. All the chlorines are arranged downside. So that this type of polymerization is known as isotactic. Okay. And next, second one, syndiotactic, syndiotactic, syndiotic, diotactic, syndiotic. Syndiotactic means if the functional groups are arranged alternatively, means one time functional groups are arranged top side and next time the functional groups are arranged downside. So like that, up and down. So up and down, the functional groups are arranged alternatively. So if that arrangement present in the polymer, those polymers are called syndiotactic. Syndiotactic polymers antam. So in this syndiotactic polymers, the functional groups are arranged alternatively. Alternative arrangement. For example, take this polymer and so in this polymer, one functional group is downside, and in the next unit, that functional group is arranged upside, and next to unit, the functional group is downside. Like this, the functional groups are arranged alternatively. Okay, ఒకసారి డౌన్ సైడ్ వస్తే నెక్స్ట్ టైం అప్ సైడ్, నెక్స్ట్ టైం డౌన్ సైడ్, అలా ఆల్టర్నేటివ్ గా అరేంజ్మెంట్ ఉంటే దాన్ని ఏమంటాం? సిన్ పాలిమర్స్ అంటాం. అండ్ నెక్స్ట్ ఫైనలీ ఏటాక్టిక్ పాలిమర్స్ మీన్స్ so atactic polymers means there is no particular arrangement of functional groups in a polymer is known as atactic polymers. There is no particular arrangement. The functional groups are arranged randomly. That functional groups are arranged to the polymer. So those polymers are called atactic polymers. Atactic polymers means, so same example, CH2, CHCl, CH2, CHCl again downside, and CH2, CHCl upside, and CH2, CHCl downside, CH2, CHCl upside, like this. So there is no regular arrangement. That functional groups are arranged randomly. There is no regular arrangement of the functional groups, and if that arrangement happens in the polymer, those polymers are called atactic polymers. Atactic polymers. So based on the tacticity, the polymers are three types. So ఎందుకు చెప్తున్నా అంటే ఇక్కడ మనకు ఆ వర్డ్ వచ్చింది కాబట్టి చెప్పాల్సి వచ్చింది. ఓకే, సో కోఆర్డినేషన్ పాలిమరైజేషన్, ఇట్ ఈస్ ఏ స్పెషల్ టైప్ ఆఫ్ పాలిమరైజేషన్ and it is a stereospecific polymerization. In this, isotactic or syndiotic polymers are formed. In this polymerization, isotactic or syndiotic polymers are formed. And in this coordination polymerization, Ziegler-Natta catalyst, Ziegler-Natta catalyst is used in this polymerization, is used. Ziegler-Natta catalyst. So Ziegler and Natta are the names of the scientists. Scientist names are. Okay, Ziegler-Natta. So the catalyst discovered by the Ziegler and Natta. ఓకే, ఇద్దరు డిస్కవర్ చేశారు కాబట్టి వాళ్ళ పేరు మీదుగా ఆ క్యాటలిస్ట్ పేరు పెట్టారు. సో వాట్ ఈస్ జిగ్లర్ నట్టా క్యాటలిస్ట్? జిగ్లర్ నట్టా క్యాటలిస్ట్ ఈస్ tetrachloro or trichloro titanium. So Ziegler-Natta catalyst is the mixture of tetrachloro or trichloro titanium and trialkyl or triethyl aluminum. Triethyl aluminum. So the mixture of tetrachloro or trichloro titanium plus triethyl aluminum is known as Ziegler-Natta catalyst. What is the composition? What is the composition of Ziegler-Natta? Tetrachloro or trichloro titanium means titanium TiCl3 plus trialkyl means triethyl C2H5 taken thrice aluminum. So is known as Ziegler-Natta catalyst. So this is the composition of this Ziegler-Natta catalyst. So in the Ziegler-Natta catalyst, so there is a coordination bond is formed. There is a coordination bond is formed between the okay. So the structure is like this. Structure ఎలా ఉంటుందంటే so titanium trichloride, titanium, and this is the chlorine, and this is the chlorine, and so chlorine. So titanium trichloride, and next to aluminum, C2H5, and C2H5. So trialkyl aluminum. So in between okay, in between chlorine and aluminum, there is a coordination covalent bond like this. And in between titanium and ethyl group, there is a coordination bond like this. So that's why it is called as coordination polymerization. So it is known as coordination polymerization. So that coordination bond can be denoted by arrow. Coordination bond, how many bonds are there? How many types of bonds are there? Totally, how many types of chemical bonds are there? 3 types. What are they? Ionic bond, covalent bond, coordination covalent bond. గుర్తున్నాయా? ఇంటర్మీడియట్లో చదివారా చదివారు కదా. సో చదివారు కాబట్టి సో దిస్ సింబల్ denotes what? Coordination covalent bond. So in between the chlorine and aluminum, there is a coordination covalent bond, and between the titanium and C2H5, there is a coordination covalent bond. So why the electrons are donated to aluminum? So aluminum has the vacant d orbital, so that it accepts the electron pair. So that is known as coordination covalent bond. So this is the chemical composition of what? Ziegler-Natta catalyst. This is Ziegler-Natta catalyst composition. Okay, this is what? Ziegler-Natta catalyst. And for our convenience, we can write this catalyst as like this, cat R. I write here. I write like this, cat R. Cat means catalyst, and that catalyst has alkyl group, R group, alkyl group. Okay, so simply I write this catalyst as cat R. And during the mechanism ఇదంతా రాయాలంటే పెద్ద బోర్డు పడుతుంది కాబట్టి సో దాన్ని సింపుల్ గా ఇలా రాద్దాం. So what is Ziegler-Natta catalyst ante? Don't say cat R. So what is the Ziegler-Natta catalyst? It is the mixture of titanium trichloride plus trialkyl aluminum. Trialkyl aluminum అని చెప్పాలి. అవసరమైతే ఈ స్ట్రక్చర్ రాయాలి. అంతేగాని క్యాటార్ అని చెప్పదు. జస్ట్ మన కన్వీనియన్స్ కోసము ఇది రాయడం జరుగుతుంది. ఓకే, సో దిస్ ఈస్ ద ఇంట్రడక్షన్ ఆఫ్ ది కోఆర్డినేషన్ condensation polymerization or Ziegler-Natta polymerization. It is also called Ziegler-Natta polymerization. So complete అయిందా? And next ఓకే, నెక్స్ట్ మెకానిజం. ఓకే, ఒక ఎగ్జాంపుల్ తీసుకుందాం. కోఆర్డినేషన్ పాలిమరేషన్ కి ఒక ఎగ్జాంపుల్. Okay, so example, so it is a stereo specific polymerization kabatti. So here I take CH2 double bond CH3. Okay, this is the monomer, and this monomer involves in the coordination polymerization in the presence of so at lowest temperature around 50 degrees centigrade, and these monomers are involved in coordination polymerization. By that, here one polymer is formed, that is a syn diatactic or isotactic polymer. So means in this polymer, this methyl groups are arranged either downside or topside. Syn diatactic ante these methyl groups are arranged alternatively. So here I take N. How it is syn diatactic and isotactic? If I write this polymer broadly, okay, how can I write? See, we can write like this: CH2 CH3. How many units are there? N number of units are there. So just take 2 or 3 monomers తీసుకోండి. So one monomer is like this, and another monomer CH2 CH3 like this. Okay, one is downside, one is upside, and another one is downside. What is the polymer? What is the specific polymer? Syn diatactic. It is a syn diatactic polymer. It is the syn diatactic polymer. So in the coordination,
మాన్యువల్గా అర్థమైందా? then after the college కాబట్టి application and coordinator application second third is అలాగా అంటే కంపెనీ చేయకుండా సెకండ్ థింగ్ ఏంటంటే 28 నుంచి సెకండ్ వరకు షార్ట్ రేంజ్ కూడా అందరికి తెలుసు అదే కలుగుతాయి అలాంటివి కావాలి కూడా అందరికి. ఓకే రైట్, సో దాంట్లో ఎక్స్పెరిమెంట్స్ ఎవ్రీథింగ్ విల్ బి డూయింగ్ ఫర్ దట్. థర్డ్ పొద్దున రాకపోతే బ్యాక్ ప్యాకేజ్ పొద్దున్నే వచ్చి 1000 రూపీస్ ఫైన్, సెకండ్ డే 500 యాజ్ కంటిన్యూ, థర్డ్ డే ఆన్వర్డ్స్ 200 200. కాబట్టి ఫస్ట్ డే కూడా షార్ట్ వెకేషన్ తర్వాత తినొచ్చు అనుకోండి, ఫస్ట్ డే అన్నాడు 500. Right? So you have prepared lump sum of money to give to the college. If you use the student welfare fund, you can be prepared for the offset. But adhikaru మన ఎడ్యుకేషన్ చెప్పేవాళ్ళు పడాలి, అది కరెక్ట్గా చెప్పేవాళ్ళు చదువుకోవాలి. అర్థమైందా? రైట్. సెకండ్ థింగ్ రిగార్డింగ్ యువర్ స్పెషల్ mixture of memory కాబట్టి కాంప్లిమెంటెడ్ టాస్క్. మిగతా జనాలకి అన్నీ అవుతున్నాయి, ఇంట్రెస్ట్ అవుతున్నాయి. మీరు 15 నుంచి మీరు క్యాటరింగ్ స్టడీ అవ్వచ్చు, కంప్లీట్ పనిగా చేయండి. 101. థ్యాంక్ యూ.
So it is a stereo-specific polymerization. So in this Ziegler-Natta catalyst is used to form the stereo-specific polymer, and it is a syn-diotactic polymer. It is a syn-diotactic polymer. Either syn-diotactic polymer or isotactic polymers are generally formed in the coordination polymerization. Okay, right. So what is the name of this monomer? What is the name of this monomer? What is the name? How many carbons are there in that monomer? 3 carbons are there. 3 carbons are there. So that root word is prop, and double bond is there, propene. So what is the name of this monomer? Propene. Propene. Okay. And what is the polymer? Polypropene. Polypropene is the polymer. Polypropene is the polymer. So, and then mechanism. So mechanism. So mechanism of the coordination polymerization. It is also carried out in 3 steps. One is initiation, second one is propagation, and third one is termination. So in the propagation, in the first step enti initiation. Initiation. First step is initiation. So in the initiation step, that catalyst, what is that? Ziegler-Natta catalyst initiate a single monomer that is CH2 CH3. CH2 CH3. So this catalyst initiate a first single monomer and followed by the n number of monomers. Okay, in the initiation step, what is initiation? So this catalyst initiate the polymerization reaction, starts the polymerization reaction. ఏం చేస్తుంది అది? స్టార్ట్ చేస్తుంది, పాలిమరేషన్ స్టార్ట్ చేస్తుంది. ఎలా అనేది చూద్దాం. సో జనరల్ in the catalyst, so that catalyst has metal. Catalyst has metal, and in the alkyl group it has carbon. Okay, in the alkyl group that has the carbon, and in the catalyst it has the metal. What are the metals? Titanium and aluminum. All together we write as cat. Okay, and R means alkyl group, C2H5, C2H5, like that. How many groups are there? 3. So altogether we write as R. Okay, so here in the catalyst metal is there, and in the alkyl group carbon is there. So in these two, first of all, here heterolytic cleavage takes place. Heterolytic cleavage means it is a metal and it is a non-metal. So the electronegativity of non-metal is more than the metal. So that bond is shifted to which side? Non-metal side, that carbon side. So here also, here the bond is shifted to which side? It shift avutundi. That bond is shifted to this side. Okay, that alkyl group side. So then it carries positive charge, and this carries the negative charge. This alkyl group carries the negative charge. And in the presence of these active sites, that pi bond is cleaved. Heterolytically. Here also that pi bond is cleaved heterolytically, means that pi bond is shifted to left-sided carbon. Okay, and then it carries negative charge and it carries the positive charge, means that carbon loses its electrons to the left side carbon. Okay, that total pi bond is shifted to the left side. Kabatti, so here it carries the negative charge and it carries positive charge. So see here, oppositely charges are attract together. Oppositely charged atoms are attract together. Means this catalyst to attach with the negatively charged carbon, and this alkyl group attach with the positively charged carbon. So that the product become like this. Okay, ఎలా వస్తుంది? See, cat, right? Cat CH2 single bond CH CH3 and R. So this is the product, isn't it? Is it right? See, R negative charge, it is attracted by the positively charged carbon. So the bond is formed between the carbon and R. And next, positive charge catalyst is attracted by the negatively charged carbon. So that catalyst carbon. Okay, so like this, in the initiation, the first monomer is initiated by the catalyst. Which catalyst? Ziegler-Natta catalyst. So this is the initiation step. And next to propagation. Second one is propagation. Propagation means growing of polymer chain. What is the propagation? Growing of polymer chain. Growing of polymer chain is known as propagation. So in the propagation, this monomer complex. So the name of this complex is monomer catalyst complex. Monomer catalyst complex. Monomer catalyst complex. So initiate the n number of monomers. N number of monomers. So here I take CH2 double bond CH CH3. So I take here n number. So ఎలా అయితే ఈ catalyst one monomer initiate చేసిందో, similarly that monomer catalyst complex initiate the remaining monomers. Remaining monomers అన్నిటిని కూడా initiate చేసి the monomers are linked together. Monomers are linked with each other and form a polymer. Finally, a polymer is formed. Okay, so by this here the polymer chain is formed. ఎలా ఫామ్ అవుతుంది? సేమ్ cat CH2 CH CH3 R CH2 double CH2 single bond CH CH3 cat CH2 CH CH3. Okay, so this is the polymer chain. This is the polymer chain. Okay, polymer chain is formed. So similarly, n number of monomers are linked together, and at one end catalyst is there, and at another end alkyl group is there. One end catalyst is there, and another end alkyl group is there. So here, how the one monomer is initiated? So by the catalyst. So then catalyst is attached to the left side carbon, alkyl group is attached to the right side carbon. Similarly, that catalyst initiates the n number of monomers. What happens? That polymer chain has one end catalyst and another end is alkyl group. Okay, so ఇది ఎలాగైతే ఉందో ఇక్కడ కూడా అలాగే రాశాను, కాకపోతే n నంబర్ రాశాను అంతే. చూడండి ఇక్కడ ఎలా ఉంది ఇది? This unit carries left side catalyst, right side R. And similarly, this is the unit, and it has left side catalyst and right side alkyl group to the one more group, one more monomer. Okay, so this is the polymer chain, and finally we have to remove this alkyl group and catalyst by adding alkyl halides. So that is takes place in the termination step. Termination. So these catalysts are active if it remains to the polymer. What happened? The stability will be decreases. We can't use this polymer in various fields. So that we have to remove that alkyl group and catalyst. So that can be done in the third step. What is that? Termination. So in the third termination, we can remove these catalyst and alkyl group. So third step. What is that? Termination. Termination. So in the termination, so it is carried out by alkyl halide group, HX group. Okay, hydrogen halide add cheste we can remove the catalyst from the polymer chain. So catalyst CH2 CH3. Okay, so like that, that catalyst and alkyl group can be removed from the by adding HX. Okay, this is what termination. Finally, the polymer is formed syndiotic, syndiotactic or isotactic polymer is formed. Isotactic polymer is formed. The name of the polymer is polyethene. Sorry. Entadi? What is the polymer name? What is the polymer name? Polypropene. What is polymer? Polypropene. So this is the mechanism of the coordination polymerization. Coordination polymerization. Okay. So these are the various types of the mechanisms of the polymerization. So far we discussed addition polymerization, condensation polymerization, and coordination polymerization. So these are the mechanisms of polymerization completed. And next we have various polymers. So various polymers. So we have to discuss preparation, properties, and applications of different polymers. Okay, let's see. So completed. అయిపోయింది ఇది.
ఇక్కడ కూడా కేటార్ అనేది ఫస్ట్ ఇక్కడ కూడా సేమ్ మళ్ళీ ఇక్కడ
So in the initiation, that catalyst initiate a single monomer first. ఒక సింగిల్ మోనోమర్ మాత్రమే ఇనిషియేట్ చేసింది కాబట్టి సింగిల్ మోనోమర్ కి క్యాట్ ఆర్ రాసేసాం. ఇప్పుడు ఈ సింగిల్ మోనోమర్ ఏం చేస్తుంది? రిమైనింగ్ మోనోమర్స్ ను లింకప్ చేసుకుంటుంది. లింకప్ చేస్తుంది కాబట్టి ఇక్కడ ఏం రాసాం? ఎన్ రాసాం. అండ్ ఇట్ క్యారీస్ క్యాటలిస్ట్ అండ్ ఆర్. ఇది పాజిటివ్ ఛార్జ్, ఇది నెగటివ్ ఛార్జ్. ఇప్పుడు ఈ పై బాండెడ్ ఎలక్ట్రాన్స్ ఇటు షిఫ్ట్ అయితే ఏమవుతుందమ్మా? these two electrons are shifted to left side. If the two electrons are shifted to left side, the so ఇంకోటి ఈ పై బాండ్ లో కార్బన్ ది ఒక ఎలక్ట్రాన్ ఉంటుంది, ఈ కార్బన్ ది ఒక ఎలక్ట్రాన్ ఉంటుంది. ఈ రెండు ఎలక్ట్రాన్స్ కూడా లెఫ్ట్ సైడ్ షిఫ్ట్ అయింది. అంటే ఈ కార్బన్ ఎలక్ట్రాన్ కూడా దీనికి వచ్చేసింది. అంటే దట్ ఎలక్ట్రాన్ ఈజ్ ఎక్సెస్ టు దిస్ కార్బన్, సో దట్ it carries the negative charge. And here this carbon loses its own electron. Then electron would loss in kabatti it carries positive charge.
carried out by it's carried out by
HX. Generally HX means X means halogen. Maybe chlorine, bromine, iodine, like that. HCl, HBr, HI, hydrogen iodide, like. So means HX means X is the halogen. X is what? Halogen. What are halogens? Chlorine, bromine, iodine, like that. Okay, HCl, HBr, HI. Okay, alarm. Chudal. Okay. And next to some important polymers, and they are one of the polymer is PVC. One of the polymer is PVC. What is PVC? What is PVC? PVC pipes. PVC pipes are using in farming, agriculture. అగ్రికల్చర్ లో ఉంది, అగ్రికల్చర్ ఉందా? సో దానిలో పీవీసీ పైప్స్ యూజ్ చేస్తారు. సో వాట్ ఈస్ ద అబ్రివేషన్ ఆఫ్ పీవీసీ? పాలీ వినైల్ క్లోరైడ్. పాలీ వినైల్ క్లోరైడ్. పాలీ వినైల్ క్లోరైడ్ is the PVC. Okay, and see what is PVC? It is a thermoplastic resin. It is a thermoplastic polymer. It is a thermoplastic polymer means it can be recycled or cannot be recycled. Is it recycle? Can we recycle the PVC pipes? Okay, it is a thermoplastic polymer means it can be recycled. We can recycle. So kabatti it is a thermoplastic polymer. It is a thermoplastic polymer. It is a thermoplastic polymer. Okay, and next to it is formed by the addition polymerization. It is formed by the addition polymerization. It is formed by addition polymerization. So then preparation. So preparation of the PVC. Preparation of PVC. Say CH2. What is the monomer in the polymer? What is the monomer in the polymer? CH2 double bond CHCl. This is the monomer. What is the name of monomer? What is the name of monomer? Vinyl chloride. Vinyl chloride is the monomer. In this polymerization, I take N number. Okay. And these monomers are involved in the addition polymerization in the presence of benzyl peroxide. Benzyl peroxide, and so near about 30 to 50 degrees centigrade. At 30 to 50 degrees centigrade, in the presence of benzyl peroxide, these monomers are involved in which polymerization? ఈ వాయిస్ ఎక్కడి నుంచి వస్తుంది? Okay, so in the presence of benzyl peroxide and heat, these monomers are involved in which polymerization? Already we discussed this type of polymerization so far. So always in the presence of peroxides and heat or light, that monomers are involved in the free radical addition polymerization. Free radical addition polymerization. So these monomers are involved in the free radical addition polymerization and form the polyvinyl chloride. Polyvinyl chloride. So take N. So this is polyvinyl chloride, PVC. So this is the preparation method. And next to properties. So properties of the PVC. So it is a white color. It is a white color powder. White color inflammable polymer. Next to it has specific gravity is 1.33 grams per cc. It has the specific gravity that is 1.33 grams per cc, and its melting point is 148 degrees centigrade. That melts at 148 degrees centigrade. Okay, and it resists to chemicals. It resists to chemicals, but it not stable to sunlight. It not stable to sunlight or heat, so that it undergoes degradation. It undergoes the degradation. When the PVC is exposed to the continuously sunlight, what happened? It undergoes degrade. It undergoes the small layers are detached from the PVC. పగిలిపోతుంది. ఎండకు పెట్టిన అనుకోండి, ఆ పీవీసీ పైప్స్ ఎండకు పెడితే ఏమవుతుంది? కొన్ని రోజుల తర్వాత పగిలి బ్రేక్స్ వస్తాయి, బ్రేకేజెస్ వస్తాయి. అంటే ఏంటి? ఇట్ నాట్ స్టేబుల్ టు ద సన్లైట్ అండ్ హీట్. ఓకే, సో ఇన్ ద ప్రెసెన్స్ ఆఫ్ సన్లైట్ ఆర్ హీట్ ఇట్ అండర్గోస్ ద డీగ్రేడ్ అయిపోతుంది, అంటే క్లోజ్ అవుతుంది. సో దీస్ ఆర్ ది ప్రాపర్టీస్ ఆఫ్ ది PVC. Okay, and next applications where we use this PVC ఎక్కడ యూజ్ చేస్తాం? సో హియర్ ద PVCs ఆర్ రాసుకున్నారు అది. సో PVCs are two types, plasticized PVC and unplasticized PVC. Please, plasticized PVC, unplasticized PVC. Okay, plasticized and unplasticized PVC. So applications. So plasticized PVC. So it is soft in nature. Plasticized PVC has soft గా ఉంటుంది. So that plasticized PVC is used in cameras, radio and television components. Okay, cameras, radio and television components లో plasticized PVC యూజ్ చేస్తాం. అండ్ నెక్స్ట్ unplasticized PVC means it is a rigid in nature, hard గా ఉంటుంది. Soft PVC, hard PVC. Okay, plasticized PVC, unplasticized PVC. It is a rigid in nature, rigid గా ఉంటుంది. So that unplasticized PVC is used to make helmets గాని. Okay, and tires and cycle, bike, mud guards ఉంటాయి కదా, mud guards. That mud guards are prepared by the or synthesized by the or made by the unplasticized PVC. The hard type of PVC can be used to prepare helmets ను, and తర్వాత టైర్స్, సైకిల్ అండ్ బైక్ mud guards. Okay, so వీటిని తయారు చేయడానికి ఈ PVC ని యూజ్ చేస్తారు. దిస్ ఇస్ అబౌట్ ది PVC. ఓకే, రైట్ ద ప్రిపరేషన్, ప్రాపర్టీస్ అండ్ అప్లికేషన్స్ ఆఫ్ PVC అంటే ఇదంతా రాయాలి. సో ప్రిపరేషన్, ప్రాపర్టీస్ అండ్ అప్లికేషన్స్. సో 3 సైడ్ హెడ్డింగ్స్ పెట్టుకుంటూ రాయాలి. అండ్ నెక్స్ట్ టెఫ్లాన్. మనకి సిలబస్ లో ఉన్నది టెఫ్లాన్. ఓకే, అయిపోయిందా? ఇంకా కిందిగా So next polymer, Teflon. Teflon. So the name of the chemical name of the Teflon is polytetrafluoro polytetrafluoroethylene. Polytetrafluoroethylene. Polytetrafluoroethylene, and it is also called fluan. It is also called fluan. Okay, it is also called fluan. So what is Teflon? Teflon is a thermoplastic. It is a thermoplastic polymer. It is a thermoplastic polymer, means it can be recycled. It can be recycled. Okay, and it is formed by, ఎలా ఫామ్ అవుతుంది? It is formed by the addition polymerization. It is formed by the addition polymerization. It is formed by addition polymerization. Okay, and next to preparation. Preparation of this polymer. How can you prepare? ఎలా ప్రిపేర్ చేస్తాం? So to prepare this polymer, here we use tetrafluoroethylene. Tetrafluoroethylene is the monomer. Tetrafluoroethylene is the monomer. So this is the monomer. So this is the monomer. So I take here n number. In the presence of same benzyl peroxide. In the presence of benzyl peroxide and some pressure and heat. Some pressure and heat. Okay, so this is the what is the tetrafluoroethylene. Tetrafluoroethylene involves in which type of polymerization? Huh? In these monomers are involved in addition polymerization. In that particularly the presence of benzyl peroxide, heat, free radical, addition polymerization. Addition polymerizations are again three types: free radical, cationic and anionic. Free radical చెప్పుకున్నాం, ఎక్స్ప్లెయిన్ చేసాం. సో ఇన్ ద ప్రెసెన్స్ ఆఫ్ పెరాక్సైడ్స్, ఎప్పుడైనా పెరాక్సైడ్స్ వచ్చిందంటే గుర్తుపెట్టుకోండి, పెరాక్సైడ్స్ అండ్ హీట్ ఆర్ లైట్ వచ్చిందంటే గుర్తుపెట్టుకోండి ఫ్రీ రాడికల్ అడిషన్ పాలిమరైజేషన్. సో దీస్ tetrafluoroethylene are involved in free radical addition polymerization and produces Teflon. Produces the Teflon like this. Teflon. So next to properties. Properties. So what are the properties of Teflon? Okay. So it is a white color, white colored rigid polymer. It is a white rigid polymer. White rigid polymer. Endama. Okay. And next to it is a white rigid polymer. Next to it has high melting point, that is 327 degrees centigrade. So it has high melting point. How much it is? 327 degrees centigrade. And it extreme, it has extreme resistance to resist to chemicals. It extreme resist to chemicals means all the carbons carries highly electronegative atoms. Fluorine is the highest electronegative element. So that the Teflon has highest electronegative atoms, so that it has extreme resistance to chemicals. Means this Teflon not reacts with the chemicals. A chemicals to kuda react kaadu, right? And next to it is a good electrical insulator. Good electrical insulator. Good electrical insulators. Okay. So these are the various properties of the Teflon. And next to applications. Applications. So where we use this Teflon. So it is used to make insulation parts. It is used to make insulation parts like cables, wires, etc. కేబుల్స్ వైర్స్ తయారు చేయడానికి ఇది టెఫ్లాన్ యూజ్ అవుతుంది. ఎందుకంటే ఇట్ గుడ్ ఎలక్ట్రికల్ ఇన్సులేటర్. ఇట్ నాట్ అలోయింగ్ ద కరెంట్. టెఫ్లాన్ నాట్ అలోయింగ్ ద కరెంట్, సో దట్ ఇట్ ఈస్ యూజ్డ్ టు మేక్ ద ఇన్సులేషన్ పార్ట్స్. ఇన్సులేషన్ పార్ట్స్ మీన్స్ వైర్స్, కేబుల్స్, సో etc. అండ్ నెక్స్ట్ సో used to make chemical carry pipes. Chemical carry pipes and chemical tanks, etc. ఎందుకంటే ఇట్ రెసిస్ట్ టు కెమికల్స్ రెసిస్ట్ గా ఉంటుంది కాబట్టి యూజ్ టు మేక్ కెమికల్ క్యారీ పైప్స్ కెమికల్స్ ని క్యారీ చేయడానికి, కెమికల్స్ ట్రాన్స్ఫర్ చేయడానికి యూజ్ చేసే పైప్స్. కెమికల్ క్యారీ పైప్స్. ఓకే. అండ్ కెమికల్ ట్యాంక్స్ వాటిని తయారు చేయడానికి కెమికల్ ట్యాంక్స్